Imagine being able to see with your ears and navigate through complete darkness like bats, or explore the depths of the ocean without any visual cues like dolphins. Don't you think? Sound is like a superpower for bats and dolphins. These fascinating creatures use sound to see their surroundings and find food. This extraordinary ability is just a part of their daily lives. To better understand these magical effects of sound, we need to study the basic aspects related to sound more thoroughly. In this video, we will study the topics reflection of sound, range of hearing, and applications of ultrasound. Let us start with the first topic of this video, the reflection of sound. Have you ever wondered how echoes are created, or why you can hear your voice bouncing back at you in an empty room? It's all because of the incredible phenomenon called the reflection of sound. Just like light, sound waves can bounce off solid or liquid surfaces, creating fascinating effects in our everyday lives. In this exciting topic, we'll explore echo and reverberation, and understand how it plays a role in our surroundings. So what is echo? An echo is a sound that we hear after it bounces off a reflecting object, like a tall building or a mountain, and returns to our ears. For example, when we shout or clap near a reflecting surface, we hear the same sound again a little later. To hear a distinct echo, there needs to be at least a 0.1 second gap between the original sound and the reflected sound. The distance between the source of the sound and the reflecting surface also affects the echo. For instance, at a temperature of 22 degrees Celsius, the minimum distance should be around 17.2 meters for us to hear a clear echo. Echoes can be heard multiple times due to successive reflections, like in the case of rolling thunder, which is caused by sound reflecting off multiple surfaces like clouds and land. Now that we have a basic understanding of echoes, let's explore the concept of reverberation, which is closely related to echoes but occurs in a specific environment. So, reverberation is the echoing of sound in a large space, like a big hall or auditorium. When a sound is made in such a space, it bounces off the walls and ceiling, creating echoes that continue until they become too quiet to hear. This can make it difficult to clearly hear sounds in the space, such as someone speaking or music playing. To reduce this unwanted echo effect, the surfaces of the room, like the walls, ceiling, and seats, are covered with materials that can absorb sound, such as fabric or rough plaster. This helps to minimize the reverberation and improve the overall sound quality in the space. Now that we've explored the concept of sound reflection, let's take a look at various applications of multiple reflections of sound and how it benefits us in everyday life. So, reflection of sound is used in various ways to enhance and direct sound in different settings. In instruments like megaphones, loudhailers, and horns, the sound is directed towards a specific direction through a conical opening. The conical opening narrows the spread of the sound waves, causing them to propagate in a more linear, focused direction. This results in the sound waves traveling towards the intended audience without spreading out in all directions. This focused projection helps the sound to maintain its intensity over a longer distance, making it easier for listeners to hear the sound clearly. Stethoscopes, used by doctors to listen to internal body sounds, utilize multiple reflections of sound within their tubes. A stethoscope consists of a chest piece which houses a diaphragm or bell, a hollow tube usually made of rubber or plastic, and earpieces, which are worn by the doctor. When the chest piece is placed on the patient's body, the sound waves produced by the internal body sounds are picked up by the diaphragm or bell. These sound waves then enter the hollow tube. Inside the tube, the sound waves encounter the inner surfaces of the tube walls. Due to the shape and material of the tube, the sound waves undergo multiple reflections as they bounce back and forth inside the tube. This process effectively amplifies the sound waves, as the multiple reflections cause the waves to combine and reinforce each other, increasing the overall amplitude of the sound. This amplification is essential because the internal body sounds are typically very faint and difficult to hear without this enhancement. As the sound waves continue to travel through the tube, they eventually reach the earpieces, where they are transmitted into the doctor's ears. In concert halls, conference halls, and cinema halls, the ceilings are usually curved to ensure that sound reaches all areas of the space after reflecting off the surfaces. After having a thorough discussion on reflection of sound, it is time to move to the next topic: range of hearing. The range of hearing for humans varies, with the typical range being between 20 Hz and 20,000 Hz. This means that we can hear sounds that fall within this frequency range. However, as we age, our sensitivity to higher frequencies decreases. Children under 5 years old and some animals, like dogs, can hear frequencies up to 25 kHz. There are also sounds that exist outside of our hearing range. Sounds with frequencies below 20 Hz are known as infrasound or infrasonic sound. These low-frequency sounds are used by animals such as rhinoceroses, whales, and elephants for communication. Interestingly, some animals can detect infrasound produced by earthquakes before the main shock waves begin, which might explain why they seem to be alerted before an earthquake occurs. On the other end of the spectrum, sounds with frequencies above 20 kHz are called ultrasonic sound or ultrasound. Animals like dolphins, bats, and porpoises produce and utilize ultrasound for various purposes, such as navigation and communication. Finally, let us explore the last topic of this chapter: the applications of ultrasound. Ultrasound has several applications, some of which are discussed here, such as cleaning. Ultrasound is used to clean hard-to-reach or complex-shaped objects, such as electronic components or tubes. The high-frequency waves remove dust and dirt from the surfaces, providing thorough cleaning. Detecting flaws in materials. In industries, ultrasound helps in detecting cracks and defects in metal blocks used for constructing buildings, bridges, and machines. The waves pass through the metal, and the defects causes reflection, indicating the presence of flaws. Medical imaging. Ultrasound is used for imaging internal organs of the human body, such as the liver, kidneys, and gallbladder. This helps doctors detect abnormalities, like stones or tumors. This technique is called ultrasonography. Echocardiography. Ultrasound waves are used to create images of the heart by reflecting off its various parts. This allows doctors to examine the heart's structure and function. Pregnancy monitoring. Ultrasonography is used to examine the fetus during pregnancy to detect any congenital defects or growth abnormalities. Kidney stone treatment. Ultrasound can be used to break small kidney stones into fine grains, which can then be easily flushed out of the body through urine. In conclusion, sound plays a vital role in our lives, from the calming effects of nature to the various applications of ultrasound in medical imaging and industrial processes. Understanding the principles of sound reflection, the range of human hearing, and the applications of ultrasound allows us to appreciate the significance of sound in our everyday lives. By studying these aspects of sound, we can better harness its potential and continue to explore new ways to use sound waves for our benefit. We hope this video has been beneficial in assisting you to understand the chapter on sound. To enhance your learning and improve your academic performance, try using the EduRev app. It offers chapter summaries, engaging lessons, and quizzes focused on each chapter, all conveniently accessible at one place.